What up, everybody? InstructaBeats back again here with our magic squares lesson on solving them, right? How do you solve a magic square? This is you. People think this is really hard, but really it's just a thought process behind it, breaking it down into simple steps to follow every single time. So let's check it out and see what our objective is today. Our objective today you will be able to solve magic squares to find out the missing numbers. Hopefully at this point you've checked out our magic squares. What are they? If you're on this video, hopefully you know what a magic square is. If not, get out of this video, check out our other video on what magic squares are, and then come back to figure out how to solve them. When we're talking about magic squares, we're talking about two different scenarios. So a lot of times when you get a magic square and you're trying to solve it, you'll actually be able to use one of the columns or rows to figure out the sum of our magic square. Right here, you can see that they've given you the three numbers that make up a column, so that way you can see that the sum of all the columns, rows, and diagonals has to be 15. And that makes it really easy because now you can just kind of set up a basic algebra equation. Sometimes though, it gets a little tricky and they give you a magic square with missing pieces where you don't know the sum. Right here, you can see that none of my columns, diagonals, or rows have all three numbers, so I'm not sure what all of those numbers have to equal. I'm not sure what the sum of the columns or the rows or the diagonals is. And that's going to be a completely different thought process. There's going to be more steps involved, but you're also going to feel better at the end when you solve that one because it is a little bit trickier. So looking at these two different scenarios, okay, if you come across, I like this little flow map right here, right? So if you know the sum, if you're looking at it and you have a column or a row diagonal with all three numbers, then all you're going to do is you're going to use that sum to set up a simple equation to find each missing square for the rest of your magic square. Okay, and we'll do an example of that. If you come across one and the sum is unknown, then you need to go ahead and follow our InstructaBeats super secret plan, which is magic. It works every single time, all right? You're going to learn it, you're going to love it, you're going to be all about it. Before we get to the two practice problems we have for this lesson, let's go ahead and find out what the super secret plan is. All right, our super secret plan. Step number one, okay, and by the way, when I say RCD, that means row, column, or diagonal. Way too long to put on one picture, okay? So step number one, we're going to find a square that is shared by a RCD, a row, column, or diagonal, with two squares filled in, so you know two of them, and a row, column, or diagonal with only one square filled in. That's a lot of words. I will show you an example of what I mean. It's a lot more simple, just kind of wordy. Step number two, you're going to use your algebra knowledge to set up an equation, okay? And then step number three, you're going to figure it out. We're just going to figure it out, okay? We're going to use these three steps. This is our super secret plan. We only need this if we don't get a magic square where three of the squares are filled in to help us figure out the sum. Let's take a look at practice number one and use our flow map to help us figure out what to do. All right, here's our first practice. If you want to pause the video and try this one by yourself, go ahead and do that. I will point out to you that you already know the sum. So this is one of those sum known ones because this diagonal tells you when you add them up that your the sum of each row, column, and diagonal has to be 24. Okay? If you want to try it from here, go ahead and pause it and then push play when you're ready. Hopefully you just paused it and tried it. If not, don't worry about it. So now what I want to do is I know that each column has to be 24. So right here for this row, I know that 4 plus 8 plus my missing number has to equal 24. So I just set up a simple equation. Obviously I'm going to add those together and I can rewrite this as subtraction and I see that C has to be 12. So now I can change C and make it a 12. Okay, now that I have that one, I can erase all of this. And now I'm looking for another one where I know two of the pieces and I'm missing the third. And now right here for this column, now that I figured out 12, I know 3 plus, oh, sorry, I should have left 24 right there. 3 plus 12 plus T has to equal 24. I add these together, that's 15. So 15 plus what equals 24? You can rewrite this as subtraction, and you see that T equals 9. So now I can change T and make it a 9. It's like magic every time I do it. Now at this point, we've kind of got the ball rolling and we can fill out the rest. Now, I can't do the middle column yet right here because I only have one of the squares that I know. I guess technically they look like rectangles, but I can find out A because I know that 13 plus 9 plus A, right? I can use this column right here to help me figure out A. And then once I figure out A, I can figure out Z pretty easily, okay? Once you get started, it's pretty easy. You just do the same thing over and over and over again. It's just a process, right? So I'm going to add these together. That's going to be 22. So obviously A is going to have to be 2 because 22 plus, A equals 2. And I can change A to 2. And voila, there you go. And now I only have one box missing. And now I can figure out this column. So 2 plus 8 plus Z had to equal 24. You combine what you know. And right here, you can either rewrite this as subtraction or use addition to help you out. And you figure out that Z has to be 14. Okay? And we can change Z to 14. Now the best part about this is you don't have to rely on anybody else to check your answer because we figured out that each column, row, and diagonal has to equal 24. You can just quickly check a random diagonal, right? So 7 plus 8 plus 9 should equal 24. 7 plus 8 is 15 plus 9 would be 24. 13 plus 4 plus 7 also equals 24. So you can self-check for these. For our practice 1, we knew the sum, right? They gave us 3 squares in a row to help us figure that out. And it was pretty easy once we did that. We just had to show a little bit of work to help us figure out these squares we didn't know. Here we have practice number 2, and here you can very clearly see that this is a sum unknown problem, right? You don't see any rows, columns, or diagonals that have all 3 filled in, so we're not going to be able to figure out our sum right away. But what we can do is follow our InstructaBeats super secret plan. A lot of people think these are really hard problems, but in fact the math is not difficult to understand. It's just a process that you have to use over and over again. It takes the mystique away from it, and really it's no longer a magic box. It's just a process that you follow over and over again. So let's take a look at this, and I know the steps were really wordy, but let me show you what I mean with a visual. First of all, we want to find a square that is shared by a row, column, or diagonal with 2 squares filled in, and a row, column, or diagonal with only 1 square filled in. Right here, I have found a square that is shared with a column that has 2 filled in, and a row that only has 1 filled in. That's all that step means. So check to both of those, okay? And really what we're going to do is we're going to use this square they have in common to help me figure out the other square in my row with only 1 number filled in. We're going to be looking for x. So now we need to set up an algebra equation to show my knowledge. So I have 22 plus 14 plus a number that I don't know, that's my circle right there, is going to equal the same number plus x plus 21. All right. Now, here's the really cool thing about algebra, right? Whatever you do to one side, you have to do to the other side. We can use our subtraction property of equality to get rid of this number because we know it's the same on both sides. If it was 5, we could take away 5 from both sides. If it was 1,000, we could take away 1,000 from both sides. And what that allows us to do is to rewrite a really simple problem where all we're doing is looking for x. So when I combine what I know this would be 36 is going to equal x plus 21. So what number, when I add it to 21, is going to get me 36? Or you could rewrite this as subtraction, and you're going to figure out that x has to equal 15. So I used my number that they had in common to actually help me find my x. Now that I know my middle square is 15, I can go, oh, sorry, I forgot to check it out. I figured it out. Now, all I have to do is go back and start again. So let me erase this, and I'm just going to start the same thought process over again. So I'm looking for a square that has a row, column, or diagonal with 2 squares, and it's shared by a row, column, or diagonal with only 1 square filled in. So right here, I found this diagonal has 2 filled in, and this column only has 1 filled in. You could have also used this row up here. It doesn't really matter as long as you meet those requirements. Now we're going to set up our algebra equation. So 14 plus 15 plus my unknown number is going to be equal to my unknown number plus 21 plus x. So I'm going to use the one they have in common to help me look for my other one. Again, I'm going to use my subtraction property of equality. I'll get rid of the number that is the same. Even though I don't know what it is, I can take it away. And I have 14 plus 15 is equal to 21 plus x. When I combine these, that's 29. So 21 plus x equals 29. What number could x be? And obviously that would be 8. You could also subtract to figure that out. And like magic, my x becomes an 8. Now I have filled out an entire diagonal with 3 numbers that I know. Now I can find the sum, and I can see that my diagonal gives me a sum of 45, which means the rest of them have to give you a sum of 45. So now you can just do simple equations such as 8 plus 21 plus a number you don't know equals 45. And you can solve these, right? So 29 plus something equals 45. You can rewrite this as subtraction, and you would get the answer of 16. So now you know this one is 16. You've completed this diagonal, so you can actually check it if you'd like. So 14 plus 15 is 29, plus 16 would be 45. Okay, so you can see it works. Now all you have to do is find the empty box, just like we did for practice number 1, that has 2 of the squares filled out, and you're looking for that third one. And you can easily solve the rest of this. So if you follow that same process that we just did, you'd figure out that this was 7, this one was 23, and this one was 9. Okay? Again, there's nothing magic about a magic square. If you follow the steps that InstructaBeats Super Secret Plan over and over and over again, you start to figure out, wait a minute, the math isn't hard. I just have to use the same thought process over and over and over again. Hopefully this has helped. If you're looking to make your own magic squares, to test other people you know and watch them struggle and laugh at them, but then teach them the super secret plan so that they can solve them too, please check out our teacher. I know it's made for teachers, but anybody can use it. Teacher DIY, building your own magic square video. We have an awesome magic square generator that will teach you how to use, and you can make as large or as small or as hard of magic squares that you want with decimals, fractions, even negative numbers. Again, thank you so much for checking us out. We would love for you to subscribe and check out our other videos, lessons, songs, and resources. We appreciate you. InstructaBeats out.